So yeah, what's your name? Clyde? Okay, Clyde's gonna give a talk now, and good luck.
Thanks. Okay. Every once in a while there's a breakthrough in genetics or something to do with it. You look on Slashdot, the discussion of the article, somebody always goes, oh yeah, well, you know, it's all going to turn into like that movie GATACCA. And somebody else right away pops up with, oh, come on, take your tinfoil hat off. Do you have any idea how often the sequence GATACCA probably shows up in the human genome? So I decided to quantify that. Unfortunately, the way I initially set out to do it was, okay, I'll read the file in, I'll clean it up, I'll do a massive join, and then to get the other, you know, the way DNA is set up, you've got two sides. You have to compute the reverse complement. So by the time I suck in the text file, and then take another quarter gig in the case of chromosome number 1, do a join, and then do the reverse complement, and I don't know if it's taking up a separate quarter gig for each of the reverse and the complement or not. It gives up. So I decided to go in the other direction. Just, you know, totally hit us and said, fine, I'll do it one character at a time. Well, I tried that and I was successful. So I wound up with a good textbook example of what many of you may do a lot of, is go through each file, each line, each character, and do something with it. How many of you wind up doing a little bit of that? Okay, so it's got some applicability. In this case, I'm matching a pattern, which is also known as a motif. So if I say motif, that's what I'm referring to. First problem I ran into is fine, but now I don't have the reverse motif, the reverse complement. That was easy to solve. Instead of looking for GATACCA in the reverse complement, I looked for the reverse complement of GATACCA in the regular sequence. So, but of course, that introduces two new problems. One, I now have multiple patterns to look for, as well as the framing problem. If I start with the first T in that pattern there, then by the time I realize I'm not matching, I may have passed up other opportunities to look for a pattern that really was there. So what I did is I came up with this idea of just saying, I'm going to create this soup with possible matches. It, you know, one of the things that is a bonus that this method turned out to have is that I could scale this to dozens, hundreds, thousands. I'll settle on the technical term oodles. I could be matching oodles of patterns. And what I did is I decided I'd have this pool of objects, or this soup, I'll keep calling it, which just refer to whichever motif I'm using, trying to match, and how far into it I've gotten. Okay, so they program again. For each file, for each line, clean up the line, filter out the comment lines, get rid of the new line characters. In this case, it turned out I had to upcase everything on a line-by-line basis. Then for each character, test the ongoing bots, or whatever you want to call them. I started calling them objects. They're not rigorously objects, but they're objective. To see if they fail or pass or have to keep cooking. And then add new candidates as something starts matching the first character of the various motifs. So of course the first thing I did is write it in Perl. Perl, it was a good choice to start with Perl because I had to do things the hard way first. And then once I got to Python, and I'm also starting to do it in Ruby, things were easier. One of the problems with Perl is you can't have an array of arrays, or can you call them either lists or arrays in Perl, in Python? Lists, okay. You can't have a list of lists in Perl. You can have a list of pointers to lists, but the dereferencing makes my brain hurt. At one point I couldn't figure it out. I put in a call for help on the Chicago Perl Mongers email list and got a quick response from Randall Schwartz, who's essentially the guy who wrote the book that answers this question. So, and of course for me the reassurance was the answer was in a book called Intermediate Perl, which reassured me that I'm no longer doing just novice experiments. Now, a lot of you probably run into this. Counters like, position 1, position 2, position 3, offsets, offset of 0, offset of 1, offset of 2, as well as I've got this concept of an offset, but the motif size isn't in offsets, it's in actual size, which is more like a counter. Any of you run into problems where you have to reconcile doing, counters and offsets? Well, I wound up writing the code so that I could reconcile all 3 of those ways of viewing the counter thing. I started using, through each iteration, it starts as an offset, which is what I properly should be referring to it as. And once it passes the test to see if it matches the appropriate character, then I increment it. So I'm post-incrementing, and that makes it suddenly become a counter. It's now counting position 1, position 2, position 3, which is just about the right time for it to be compared to the motif size. So if on the last iteration, if the motif size is 7, it comes in with this 6. I'm comparing the current nucleotide with offset 6. It passes, I increment that 6 to a 7, it's the 7th byte, and now I can compare the 7, as in I finished with 7 bytes, with the motif size, which is 7, and go, okay, that one finished. So miraculously I managed to reconcile that particular problem. Okay. Here's the main code for going through the file. I have a list of files, a list of motifs, a list of totals, and I flag that as a potential problem because if I change the size of the motifs list, I have to have a mechanism that's going to change the size of the totals list as well, and I haven't done due diligence on that. But at least I recognize that that could become a problem. So for each file in files, I initialize my counts. Again, that should scale according to the size of the motifs list. I start with an empty vat of soup, and then for each line in each file, there are certain lines in these files that are essentially comments, so I skip those. Then I strip out the new line characters and upcase it, and then for each character in the line, I work on it. I found that in Python and in Ruby, it was a little bit easier to do this structure than it was in Perl. Okay, and then this is the guts of the individual loops. I start with a hold list because I'm going to keep pulling things out of the soup and they either disappear or migrate into the hold list. So for each one of those in the soup, if I, which is the current nucleotide, the current character on the current line in the current file, if it matches the motif, I've got a pointer to the particular motif and then a pointer, an offset into that motif, see if it matches. If it matches, I increment that pointer, then I have to decide whether it's finished or not. So if that counter matches the size of the motif, it gets discarded, but I increment the counter. You know, I've successfully gotten another match, otherwise I put that into the hold. And then once I've done all those, I put the contents of hold back into soup. And then I go looking for new matches. See if anything matches the first character in any of the motifs. If it does, I add that to the soup. And that's pretty much it. Going in, I thought, boy, this is going to be a really hairy, object-oriented thing. And I'm almost disappointed that it boiled down to that little code. So before I take any questions, a quick poll. How many of you found this informative? How many of you thought it was a real yawner? How many of you thought, well, that's interesting, I suppose, but it's got nothing to do with web apps? Okay, that's a relief. Okay.
So what's the answer? How many?
Oh. Well, when I originally did it, I came up with about 170,000. And then I realized that the particular human genome files I got had mixed uppercase and lowercase, which encoded, if you have a lot of these mindless short little repetitions, they do the work of lowercasing those so that if you want, you can skip those and ignore them. So I realized I only matched the ones that were properly uppercase. I went back, I added that line that upcases them line by line. It came up with, instead of 170,000, it's more like 1.35 million. So yeah, there's a bunch of them.
Whose genome was that?
The human genome, the one I'm using is HG19, if that tells you what I'm looking at. Yeah, as far as I know, that's the guy who started the scattergun approach to the genome mixing. It turned out, yeah, all along they were using J. Craig Venter's genome. So,
But now there's like 20 people have been completely sequenced, right? So
I've heard
did
that.
you try all
And there may
of
be
them?
thousands. Well, yeah. When I can afford a computer that'll hold all that information. In both Perl and Python, it runs for about 3 to 5 hours. I expect it to take a day and a half in Ruby.
Well, it's going to be a weird question. When you wrote it, you wrote it as a script. Well, you gave text data.
No, I just wrote it as a script.
There's one good known thing about Python code. If you take code that's in a script called Black and you move it into a function, it'll often
What do you want to do it?
Okay.
like twice. This is how it's done.
Okay, that was one thing I wanted to get out of this presentation is
I'd be really curious.
how can I make this faster? How can I do it better with it?
One way to make it way faster is probably to write it as
Right at what?
Yeah, but how do you match across lines with sets?
Oh, there's some way to do it with sets.
You have to either join the line.
Yeah, matching across lines is the problem.
Come up with
No.
partial matches and.
I don't think so.
Okay, I'll look into
Not
it.
in set. I said to do with set.
Yeah.
Before the talk, I Googled the GATACCA that you had, and Google came back with, did you mean GATACCA with a different spelling? So just so you know, the movie was spelled differently.
How was it spelled?
Oh, no. I think it was just one T.
One T and two C's, I think.
One T and two C. Okay.
Google it, you'll see immediately what the...
I'm sure there'll be 0 hits.
Over again.
It's copyrighted.
Yeah,
How long did the
from
run take,
scratch,
sir?
Get the whole thing over.
including forgetting all
The
the
run took 30
optimizations they made.
Just do
Sure.
another one.
Maybe it'll fit in. Maybe the large file will fit in memory this time.
Page 19.
How long did the run take, just to the question?
About 3 to 5 hours. Yeah.
So, yeah, that's not an easy change to make. Oh, well.
You had a
Oh, what's the input format? Like, what do the new ones mean anything? So just, so
Oh.
it's not just one long string or?
it's usually something in English saying, you know, what this file is about, or some code for how you tell this particular chromosome files from other chromosome files. Something meaningful to humans, but not a gene sequence.
I'm sure it would run faster than like processing the file, so it's just like one string of characters or something like that. So it's doing that at the same time.
Okay.
Oh, just string.
Okay, is that it?
Yeah.
Thank you. Oh, yeah.
I know you guys right
Well, that's
here.
good.
Test data where you knew what the answer was.
No,
At work in
no, I am assuming they got it.
Greater than sign, you just,
I'll have to look up their spelling now and redo it. Thank you.
you just throw everybody away.
All right, so real quick, we got one column, last set of introductions. I promise. People, Joel.
Yep.